Right, so welcome back. Today we are going to do Leetcode question 269, Alien Dictionary. So the question says, there is a new alien language that uses the English alphabet. However, the order among the letters is unknown to you. You are given a list of string words from the Alien Languages Dictionary, where the string in the words are shorted lexicographically. By the rules of this new language, return a string of the unit letters in the new alien language shorted in lexicographically increasing order by the new language rules. If there is no solution, return empty string. If there are multiple solutions, return any of them. So first, we need to keep in mind is it is an alien language, so it means we don't know the order unless we find out it from the given words. And the alien language has to the given words are shorted lexicographically by the rules of this new language, and the order of the language is increasingly. So it means at the end, if there's a solution, the order has to be increased order. So let's see how we are going to approach this problem. I'm going to switch to the notebook. Give me a second. Right. So the first one, we have two words, and it's sorted lexicographically. So I mean it's sorted in order. That means that this word is greater than this word, and this word is greater than this word. This word is greater than this word. So the first one, we have 8, but A and A are the same. So we don't know which character greater than which character. But technically, we know A is greater than 8. And we have, not A greater than A is equal to A, but the B and the second character, B and B are the same. So here we cannot we actually cannot really identify this true word, which one is greater than which one based on the character, but we know the order of this word is is sorted in lexicographically. So it means A is less than B, like this. We know this, yeah. So at the end, our output is A less than B. Now the second one, we have ABC and AB. Now you can see the first one has 3 characters and the second one has 2 characters. So our comparison only looking for the smallest length. So it means we only need to compare the first 2 characters for this pair. So let's see A, right? So we know A, the first 2 characters are the same. So we don't know how to do we don't know how can we compare with them. But the weird thing is we have another C here, the length of the first words is greater than the length of sorry. There's a minor error. Instead of here is not greater than, this is less than, because it's sorted lexicographically, so it's less than. All right, so that makes sense for the second example. So we know AB and AB are the same. Now we can see the first word has the character, but the second word doesn't have the character. So it means technically the first word should greater than the second word. So it means this one is like a contradiction. So it means there's no solution for this one. Now let's look at the third example. We have the first one has 3 characters and the second one has 2 characters. Now we compare the first one. The first character, they are not the same. So it means we know from here we know W is less than E. Yeah. So then from here we can we know W less than E. But it's not enough. Like we compare each pair in the given verse, and we need to find out the order of those characters. So let me add another one. So for example, we have like A is less than B and B is less than C and R is less than F. Now how we are order those? So it means like here we can consider as A goes to B, and here is like B goes to C, and then here we know R goes to F. Right. So we can consider this like if we consider as a graph, like here A to B, and then B to C, and then we have R to F. Now we know here, if we had this graph, here we had this graph, you know, R and F are R and F. Yeah, let's do another one like F to C. Yeah, let's add another like we have F to C. So F to C like this. We know here, so we know here our 8 and R is the rules of this graph. It means there's no incoming edges for this. So it means it could be the smallest character. And then once we traverse these two, right, we decrease okay, let's just write down the incoming edge for each node. If here is 0 and 0, here's 1, 1. Here's 2. Now we know here, this one, RMA, incoming edge is 0. So it means this two has to be the smallest character. Once we traverse these two, right, and then we can decrease the degree of the neighbors of those characters. So this becomes 0 and this becomes 0. Then we know, and then we continue to explore the neighbors of the nodes that has edges of 0. So here, let's say if we start from here, and then here we'll decrease 1, it become 1. Then if we go to here, if we go to B, and then the neighbors of this decreases 1, then becomes 0. So at the end, so we will be able to traverse order character. So perhaps like if we go with R first, that will be R, and then 8, and then F, and then B, and then C. Or we can have 8 and R and B, or F, and then C. So we will have two possible solution. We can just return either one of them. So that's like this one, like, so since we use graph and we can just traverse the graph by level, and then decreasing the edge, the incoming edge for the neighbors of the nodes that we are exploring. So let's back to the coding to see how we are going to write our code. So first, we need to create our adjacency list and also the in degrees for each character. So let's call our adjacency list equal dictionary, and in degrees also is a dictionary. Now we need to have all the nodes for our adjacency list and degrees. So we need to traverse the words and then find out each character for chart in words. Then we just need to do this chart. So Elliot nodes has a list of neighbors, and in degrees chart equals 0. So see, here is our initialize. We are doing the initialization. Here is initial. And then we need to start to traverse to our character for each words that we have, and find out the pair, the order of each pair that we can get. So for I in range length of words -1, and so we end with the length of -1 because we need to check one pair, 2 words for each iteration. So our first word is words I, and W2 is the second word, is I +1. Then we want to, since we only compare the smallest, the length that has the smallest length of word, so we need to get the length of the minimum length of this 2 words, length of W2. Then we start to traverse to the character. So if like W1 J, oh not J, sorry, is I, yeah, it's J. It's not equal to W2 J. So it means we found the order of the character that we need in the word. So we just need to append it to our adjacency list. So we know like the first character less than the second character. So it means W W1J is append W2J. And then we also need to increase the degrees of W2J +1. Yeah. So now keep in mind that we talk about one of the example in the noteboard. So if our now here, since we already found the order, we just need to break up the loop and then goes to the next order. Well, if we don't find the order of the character for this pair, and if the j is equal to I minus 1, it means the last index of the word of the character that we need to check. Then we just need to compare if the length of W2, if the length of W2 is less than the length of W1, so it means we cannot find out the order of this pair. That's being said, there's no order for this pair. So we won't be able to find any solution here. So it means they are not in a increasing order. So we just need to return an empty string. And yeah. So now once we have our adjacency list and integers for each character, then we need to find out our character that has integer of 0 which is our starting point. So let's start with initialize our store as an empty list, and then we need to also capture our visited nodes into a set. So we traverse to our integers for character in integers. So if integers char equals 0, we need to just append it to our store list. So char, and then we need an order as our output as an empty list first. And then while our store is not empty, we append it. We append the nodes from there. And we also need to add the chart, update the order. And we check the neighbors. We check the neighbors of these nodes to decrease the incoming edges. So for neighbors in adjacency list of chart, then if neighbors in visited, so it means it has been visited, we just need to continue. And else we decrease the incoming edges. So that will be minus 1. So if integers is equal 0, so it means we need to append it to our stored list. So the neighbor, sorry, spelling. Okay. Then we also need to update our visit. So at the end, if the length of the orders, so equal the length of integers, it means all the characters, the length of the order equal the length of all the character in the integer. So we just need to return the order. Also, we return the empty string. Why is the empty string? If the order doesn't equal to the length of decrease, it means we won't be able to find out the order for all the character. It means we just get the partial order, not all of them. So it means there is no solution. So yeah, so let's check it. For words, sorry, syntax error for words in words. For I in range, I'll check for neighbors in adjacency list, for neighbor in visit, right? Let's check one more time. Oh, so many error. So, okay, good. Equals 0, we append it. Oh yeah. Here we also need to add it to the visit. Sure. Yeah. Then order while store. And for neighbors, if neighbors invalid, we continue, else we decrease the in degrees for the neighbors. If the degrees in degree of this neighbor is 0, we append it to store and update the visit. And yeah, let's check one more time. A, B, C. See if there's any error. Oh yeah. So if the length, well, is equal to if the length is not equal to the length of what we return empty string, we should return the order. And it's good for this one. See any syntax error. Plus one, W2 out, and J. Oh, here is not I minus 1, is L minus 1. It's the last index of the word that we need to check. Let's run it one more time. Yeah, it looks good. And let's check the example that we have here. Oh, in degree of 0 syntax error, not in degree of the neighbors equals 0. Right, it looks good. And then check one more. Oh. Check one more. Right, looks good. Let's try to submit it. Well, you can see like the performance seems pretty good. And yeah, so pretty much for this one, we mainly use reference search, BFX algorithm to solve the question. So we need to find out the order of the character through each pair. And then we use BFX to traverse to the nodes level by level. And at the end, we just need to compare the order that we get, the length of the order that we get to see if it's equivalent to the length of a unique character in the given input. If they are the same, we just need to return the order. If it's not, means there's no answer. We return an empty string. So in terms of the time complexity for this question, so we actually traverse all the character that the input has. Let's say perhaps the character is C. So if we have C as the character, so the time complexity that will be time complex. That will be a bit O of C, capital C, and the space complexity is let me see. Yeah, the space complexity is also a bit O of C because we create a number of characters is like the number of keys is the number of character that we have in the adjacency list and in the integers. So it's a bit of C. All right, so that's this question. Thank you so much for watching. If you like my videos, please subscribe. I will have more video like this in the future, and please share and like the videos. So thank you so much.